Hello, I am Sir CJ and welcome back to Physics 10. This is the second session. For this session, we have the following parts. The first one, it will be a pre-assessment. It will be composed of multiple choice items and the questions are going to be about Module 1, Electricity and Magnetism. The second part is the first activity, the first part of that activity is part A, which is titled Virtual Tour of a Radio Broadcasting Studio. And then the last part of this session is still under the same activity. It will be titled My Own Home Recording Studio for Live. This session is tackling the following learning competency, which is cite examples of practical applications of the different regions of the electromagnetic waves, such as the use of radio waves in telecommunications. Let's begin. For the first part in pre-assessment, you will be using, I think, a one-fourth sheet of paper because, we only have multiple choice items naman. For the first question, in which case or cases is electric field present? Number one, a spark jumping between two nearby rods. Number two, a charge that is momentarily at rest. Number three, a rotating bar magnet. Your options are letter A, 1 only. Letter B, 1 and 2 only. Letter C, 2 and 3 only. And letter D, 1, 2, and 3. Pause this video if you need more time. If you are through, let us proceed to question number 2. In which case can a magnetic field be produced? A. A charged comb. B. A falling glass rod. C. A welder's arc flash. D. A rolling plastic cylinder. Pause this video if you need more time. If you are through, let us proceed to question number 3. Question number 3. Which device can be used to determine the polarity of an unmarked magnet? A. A charged glass steering rod. B. A gold leaf electroscope. C. A sprinkle of iron filings. D. An improvised compass. Pause this video if you need more time. If you are through, let us proceed to question number 4. Question number 4. How will you describe the magnetic field around a straight current carrying wire? A. The magnetic field is strongest near and around the wire. B. The magnetic field consists of straight lines parallel to the wire. C. The magnetic field does not vary with the distance from the wire. D. The magnetic field gets stronger with increasing distance from the wire. Pause this video if you need more time. If you are through, let's proceed to the next question. Question number 5. Which statement about an electromagnet is true? A. The electric field surrounding a battery-powered electromagnet alternates constantly. B. The current in the electromagnet coil temporarily magnetizes the iron core. C. The electric field strength is inversely proportional to the current. D. The magnetic field lines produced are all straight. Pause this video if you need more time. If you are through, let us proceed to the next question. Question number 6. What can be inferred from the alignment of compass needles in the setup below? Looking closely, you will see the compasses surrounding the entire setup. Letter A. A permanent magnet is nearby. Letter B. The power switch was turned off for long. Letter C. The current carrying coil becomes magnetic. Letter D. There is a constant and uniform magnetic field around the coil. Pause this video if you need more time. If you are through, let us proceed to the next question. Question number 7. As part of a traffic light system, large loops of wire are buried beneath road intersections. Which of the following statements is not true about the operation of this traffic light system? A. Vehicles driven over the buried coils activate a traffic light sensor. B. The conducting loops activate a color-dependent field. C. The alternating current sent through the buried coils produce an electromagnetic field in each coil. D. A minimum number of vehicles over the coils can trigger the traffic light to change green. Pause this video if you need more time. If you are through, let us proceed to the next question. Question number 8. Complete the following statement. Moving a metallic detector past a 5 peso coin creates a secondary magnetic field that is most similar to that of blank. A. A horseshoe magnet. B. A flat refrigerator magnet. C. A current-carrying circular loop. D. A V-shaped straight wire that carries a current. Pause this video if you need more time. If you are through, let us proceed to the next question. Question number 9. During the Student Technologists and Entrepreneurs of the Philippines or STEP competition in landscaping, a water pond transformer changes 216 volts across the primary, 12 volts across the secondary. If the secondary coil has 10 turns, how many turns does the primary coil have? A. 10 turns. B. 18 turns. C. 180 turns. D. 228 turns. Pause this video if you need more time. If you are through, let us proceed to the next question. Question number 10. What basic principle enables all electric motors to operate? A. Iron is the only element that is magnetic. B. Opposite electric charges attract and like charges repel. C. A moving conductor within a magnetic field will experience an electromotive force. D. A current-carrying conductor placed within a magnetic field will experience a magnetic force. Pause this video if you need more time. If you are through, let us proceed to the next question. Question number 11. A magnet moves inside a coil. Consider the following factors. Number 1. Strength of the magnet. Number 2. Number of turns in the coil. Number 3. Speed at which the magnet moves. Your options are letter A, 1 only. Letter B, 2 only. Letter C, 3 only. Letter D, all 3 factors. If you need more time, pause this video. If you were through, let us proceed to the next question. Question number 12. Which statement about transformers is false? Letter A. A step-down voltage transformer steps up the current. Letter B. Transformers use mutual induction. Letter C. Transformers are an application of Faraday's and Lenz's laws. Letter D. A transformer can function with either an alternating current or AC or a steady current DC. If you need more time, pause this video. If you are done, let us proceed to the next question. Question number 13. What is true about the intercom system that is shown below? Your options are: letter A. The part A of the intercom system serves as a microphone only, while part C serves as a loudspeaker only. Letter B. Either parts A and C of the intercom, when switched as such, can be used as a microphone or as a loudspeaker. Letter C. The microphone part only basically consists of wires, a cone diagram, a magnet, and a coil. Letter D. The loudspeaker part only basically consists of wires, a cone diagram, a magnet, and a coil. If you need more time, please pause this video. If you are through, let us proceed to the next question. Question number 14. What transformation can take place in an improvised generator? A. Mechanical energy into electrical energy. B. Electrical energy into mechanical energy. C. Alternating current into direct current. D. Direct current into alternating current. If you need more time, please pause this video. If you are through, let us now proceed to the last question in this pre-assessment. Question number 15. A loop of conductor lies flat on a horizontal table. A toy magnet is hanging still over it, with the magnet's north-seeking pole pointing down. What happens next? A. The magnet produces a clockwise current in the coil. B. The magnet does not produce any current in the coil. C. The magnet produces an upward electromagnetic current. D. The magnet produces a counterclockwise current in the coil. Pause this video if you need more time. If you are through with the last question, let us now proceed to the checking of your work. For question number 1, the answer is letter D. 1, 2, and 3. For the next item, question number 2, the correct answer is letter C. A welder's arc flash. For the next item, question number 3, the correct answer is letter D, an improvised compass. For the next question, question number 4, the correct answer is letter A. The magnetic field is strongest near and around the wire. For the next question, question number 5, the correct answer is letter B. The current in the electromagnet coil temporarily magnetizes the iron core. For the next question, question number 6, the correct answer is letter C. The current carrying coil becomes magnetic. The next question, the correct answer for question number 7 is letter B. The conducting loops activate a color dependent field. The correct answer for question number 8 is option letter C, a current carrying circular loop. The correct answer for the next question, question number 9, is letter C, 180 turns. For the next question, question number 10, the correct answer is letter D, a current carrying conductor placed within a magnetic field will experience a magnetic force. The correct answer for question number 11 is letter D, all three factors. For the next question, question number 12, the correct answer is letter D. A transformer can function with either an alternating current AC or a steady direct current DC. For the next question, question number 13, the correct answer is letter B. Either parts A and C of the intercom, when switched as such, can be used as a microphone or as a loudspeaker. For the next question, question number 14, the correct answer is letter A. Mechanical energy into electrical energy. For the last question in this pre-assessment, question number 15, the correct answer is letter B. The magnet does not produce any current in the coil. Count the number of correct answers that you got and please indicate your score on the upper right hand corner of your paper. Thank you so much. We are now through with pre-assessment multiple choices, Module 1, Electricity and Magnetism. This is the first part of this video lesson. We are now ready to proceed to the second part. The second part is titled Activity 1, for the record, Part A, a virtual tour of a radio broadcasting studio. People readily adopt emerging technologies. The use of AV or audiovisual works, be it in film productions, in business displays, or perhaps even in education innovations, became a trend and it is here to stay and improve. Examples abound, like our growing love for the high quality audiovisual components we'll listen to and watch, or the endeavor of school stakeholders to provide projection technology in every classroom. In our school, for instance, we are using various projection technologies such as opaque projectors as well as television sets. Online, when we were still conducting strictly synchronous or asynchronous online classes, students will be watching synchronous video lessons through Google Meet or Microsoft Teams, or they can also afford some asynchronous video lessons through streaming services provided by websites such as YouTube. The rise of it all, AV of all audiovisual production, recording, and storing technology and industries were made possible because of the discovery of the link between electricity and magnetism. How does one begin to understand this partnership? I mean, for a student like you, and even for a layman such as most of us, maybe it's quite difficult for us to understand how on earth are the concepts of electricity and magnetism work together for us to see these kinds of audio and visual presentations. Now, to start understanding that connection, we have to first consider doing the following activity regarding audio recording devices. Thus, the objectives of this activity are as follows. Is that the first one, you should be capable of identifying the basic recording equipment of a digital radio studio. Classify whether devices use electricity and magnetism when used in recording studio. And the third one, the last one, is that you should start a literature search on electromagnetic induction's role in recording technology. The materials you will be requiring in doing these activities for both parts A and part B are the following. So you have to have a picture of the radio studio control and audio room, or a video clip on a radio station tour, video player, screen, and accessories. And then the last one is that you should have a pen and an activity sheet, or your science notebook will also do. Now, keep in mind that this is part A. Okay, so for the procedure, we have the following steps. The first step is that you should be capable of first getting some background, some kind of an understanding, a general understanding of or a general image, okay, of what the place looks like. So first of all, you have to read the scenario and study the video clip or study the pictures that will be shown in a while. Okay, so for the activity scenario, during non-class hours, for instance, after your last subject, or maybe during your vacant time, you frequently meet your friends playing and making music together. One afternoon, you decided to go to your local radio station to ask what equipment and software is needed to start recording at home. So you were like discovering, having a field trip, and the main objective is for you to know what kind of tools, what kinds of equipment, and what kind of software do you need to have in order to record at home. Now, at the broadcast studio, when you arrived, with the radio technician out, the staff allowed you to take some pictures inside the control room and the live audio room, like what is going to be shown in figures 1, 2, and 3. Now, this is figure number 1. So, assuming that the actual technician is out and that you were only allowed to take a photo, this is one of the photos that you guys took. This is a control room from a local radio broadcast studio, commonly known as an announcer's booth. And if we zoom in, you will see the following materials. Now, to inspect this booth, you have to pause this video. All right. So, I think that that is enough observation, and we can move forward in this activity. Remember, if you needed more time to study it, you can always pause the video. Now, step number 2 on your science activity notebook, you have to make the following table, like this one. It has 3 columns, and the number of rows, kumbaga, depends on the how many rows you're gonna need. Okay, so and also the sizes of the rows. The size depends on how much space you need to write on. So what you have to do is you have to list all the equipment that you can identify in the previous photo. So if you want to take a look at that, you can always rewind this video. Now you have to indicate with a check mark whether the equipment or device needs electricity and or magnetism to operate. Like say for instance, if you guys saw a phone in the booth, you have to decide or check under this column if you think that the phone needs electricity and if you think it also works on magnetism. Again, you have to make a check mark. Now, for this step, what you have to do is write a lot of stuff, right? So if you need more time, you can always pause this video and just continue watching it afterwards. Okay, I am assuming that you are done with your table 1 and that we can proceed now. All right. For before we continue with the next parts of this activity or this session, what we have to do underneath your tables is you have to write your answers to the following guide questions. Again, I repeat, under the tables, what you have to write are the answers only. Okay, for you to save time and maybe space as well. I'm assuming that you're gonna be writing this on an intermediate pad paper. You can just write the answers, your answers to the following guide questions. So if you're ready, let us have the first question. Question number 1. How many of the devices you identified inside the control room needs electricity to operate? Pause this video if you need more time. If you decide to continue, let us now move forward. This is question number 2. How many of the devices you identified inside the control room need magnetism to operate? If you decided to continue, let us now move forward. Step number 3. On your science activity notebook or maybe on your one whole sheet of paper, you have to make another table just like the first one that you had a while ago. What you have to do is you have to list all the equipment that you can identify in the pictures shown in figures 2, which is going to be shown in a while, and 3, which is going to be shown after a while. Indicate a check mark whether the equipment or device needs electricity and or magnetism to operate. So you are going to basically repeat what you just did a while ago. Now this one, figure 2, is a live audio room commonly known as the newsroom, which is usually separated from the control room via glass partitions. And now we're zooming in. I think that if you need more time to inspect the photo, you can always rewind this video. The next photo is figure 3, which is the back portion of a local newsroom. Let us now zoom in. Okay, I'm assuming that that is enough time, or maybe you can just pause this video if you need to inspect it. Okay, we're now gonna be moving forward. Just like table number 1, you're gonna be drawing most actually the same kind of table, but this time your reference is different from table 1. This time your reference was the live audio room or newsroom. Okay, so what you have to do is you just have to write again the name of the equipment or the device and then classify it, whether it needs electricity or magnetism by putting a check mark underneath it. Okay. Again, if you need more time, you may just pause this video. But if you have decided that you already had a sufficient number of equipment and devices, we can now move forward. Continuing now with the guide questions, we have guide question number 3. How many devices you identified inside the live audio room need electricity to operate? Pause this video if you need more time. If you have decided to proceed, let us now go and move forward. Question number 4. How many of the devices you identified inside the live audio room need magnetism to operate? Pause this video if you need more time. If you have decided to move forward, let us do so. This is question number 5. What other devices not shown in the photo may be used inside the live audio room? So think of any other device which you may actually you think is going to be needed inside the live audio room, and maybe list down at least one. If you are done answering this question, let us now proceed to the next part of this session. Let us now answer tables 1 and 2. For table number 1, this was the typical radio broadcast studio equipment or the control room or announcer's booth. For the equipment, we have microphones, which need electricity and magnetism, just like computer units and accessories. Video and web cameras only need electricity. Headphone console mixer phone, as well as audio console mixers, sound monitors or boxed speakers, and wired landline telephones, they all need electricity and magnetism. However, satellite receivers, lighting units, as well as ventilation and air conditioning units are presumed to need electricity. Now, this table is not very conclusive. These are just suggested answers. So halimbawa, meron tayong mga bagong uri ng mga devices, or maybe there are corrections, we can always talk about them inside our classroom. The next set of materials, of equipment that you can see inside the control room or an announcer's booth are the following. So you can see audio video cables, power supply units, extension wires, and manual switches. For the second table, we have the following. So this is radio broadcast studio equipment, the live audio room or newsroom. We have the following list of materials and equipment. They are also classified or identified whether they need electricity, magnetism, or both. So the first one are microphones, video, television, monitors, and accessories, video camera and recorder, headphones, digital video mixer, audio and audio video media players, microphone and video camera stands, audio video cables and power supply units, lighting units, ventilation and air conditioning units. And then for the next set, there are also wireless in-ear monitors, and I don't think that VHSs and cassette tapes have electricity and magnetism innate in them, as well as CDs, VCDs, and DVDs. There are also manual switches, and then there is a remote control. Alright. Okay, so if you are done looking at these and considering these answers, let us now proceed to the answers to the different guide questions. For question number 1, how many of the devices you identified inside the control room need electricity to operate? The correct answers may actually vary, but generally, most equipment function using electricity. So, if you listed almost all of the things that you put into your tables, then your answer to this guide question is more likely correct. Let us now proceed to question number 2. How many of the devices you identified inside the control room need magnetism to operate? For this question, the correct answer may actually vary as well, but most materials and equipment in recording rooms may have permanent or temporary actually that's or okay. All right. So that's they may have permanent or temporary magnetic nature. But generally, many materials that run on electricity have an associated magnetism to it. All right. The next question is question number 3. How many of the devices you identified inside the live audio room need electricity to operate? The correct answer may actually vary, but again, most of the equipment that you may have listed actually require electricity. All right. For the next question number 4, how many of the devices you identified inside the live audio room need magnetism to operate? the correct answer again may actually vary, and just like the answer to the preceding questions, generally many materials that run on electricity also have an associated magnetism to it. For question number 5, what other devices not shown in the photo may be used inside the live audio room? The correct answers could include timing devices, musical instruments, which could be non electric or electronic, and then alarm devices, and etc. Okay, so what you have to do before we proceed to the key concepts is you have to consider your answers in the tables 1 and 2 and guide questions 1 to 5. Your own discretion is going to be more likely used in considering your answers for those questions and tables as correct or incorrect. Okay, so it's up to you. If they're close enough, if they are bearing the essence of a correct answer, you may always just put a check mark to your own work. Okay. Now, for this part of the activity, for part A, for the record, these are the key concepts. The first one, a typical broadcast studio consists of an audio console, microphones, computers, studio monitors, and disc players. So you will always be seeing these materials in a typical broadcast studio, which could be actually kumbaga, pwede pa siya madagdagan ng iba pang mga materials as you siguro progress from a basic recording studio to a more maybe complicated one. And then the next key concept is that the audio console, that term, converts an analog audio, that is the voice, via microphone and phone calls to its digital format. Now, it also allows for the mixing of all sound sources from, say, for instance, CDs, computers, and other digital sources before being sent to the transmitter. Now, a slider controls the volume of each sound source. So it's called a slider because it typically, usually, has switches and buttons that don't actually you don't have to press. They actually are kumbaga, yeah, they're actually sliders. Like you can just slide them, so you can like control them. All right. The next and the last, I think, key concept is that the live audio and control rooms are connected by cables for the exchange of audio and digital data signal during recording, mixing, and even editing of all video audio elements digitally restored on hard drives. All right. That activity actually I think it has taken a lot of our time so far, right? But we're not yet through with it, actually. We're gonna be discussing, no, not discussing, just discussing. We're gonna be doing part B of the activity 1 for the record, which is going to be titled My Own Home Recording Studio for Life. The first step in doing this activity is mind setting. You could actually be an aspiring singer, a music artist, or a student who needs to record audio presentations, or simply one planning to have a startup home recording studio just for fun. Use Table 3, which will be shown to you, and extend your understanding of the recording industry by matching the devices in column B with their respective functions in column C with the items in column A. Now, this is quite a code, okay? It is a coding activity. You have to write the letter and the number of your coding as your answer. So let us look at the following table. Alright, I will now give you the time to inspect, to read, to analyze, and then to answer the questions that are put here in this table. So for the first underlines over here, for the first set of blanks, itong bandang malapit sa mga numbers, what you have to write, of course, it's gonna be a letter or a number. Okay, again, you will be writing a letter or a number. And then over here naman, it could be also a letter or a number. Now, if you switch them up, it's just fine for as long as, halimbawa, if you wrote A, just write A, okay? And then if you write about 3, you don't write the number. You can just write the Roman numeral. You may now start answering this table. Go ahead. Are you done? Okay, if that is so, let us now proceed to the next part, which is answering the following guide question. Which devices in Table 3 are powered entirely or partially by electromagnetic induction? The phenomenon of a changing magnetic or electric field's effect on electricity and magnetism. Pause this video if you need more time to understand the question and answer it. Are you through? Okay, let's now proceed to answering the table. The answers to the table are as follows. So number 1 is actually A5. Number 2 is E3. So A5, let's have a look at them. A is actually headphone. This is a headphone. And it is used for referencing or for checking what the mix would sound like on the equipment. This photo over here is actually letter E, a computer unit. And it is a process, it actually requires that the processor should be reasonably fast enough to record, edit, mix, store, and master a copy of the record. For the third item, number 3 is actually letter C, an audio interface, and it is where the microphones and musical instruments are plugged into, which in turn is actually connected to the computer. The fourth photo on this table is actually a digital audio software, and this is used for playing some digital instruments, MIDI, for recording, for adding effects, and mixing different sources of sound signals. The fifth item is actually called a studio monitor, and it's commonly known as speakers, but these give a sound close enough to the real sound input. Just like your computer screen can actually serve as a visual monitor, these audio monitors, studio monitors, are actually giving off some audio input for monitoring purposes. The sixth item or items are actually condensers or dynamic microphones, and they function so that the analog sound could be converted into an electrical signal. The seventh and the last item over here is actually cables. Okay, it's actually a cable, and its function is to connect audio interfaces, microphones, studio monitors, and different instruments to each other. This completes the table, and what you have here are actually 7 items or 7 points. How many did you get? All right, hopefully that you got a lot of items over here. Okay. Let us now proceed to answering the guide question. The question was, which devices on table 3 are powered entirely or partially by electromagnetic induction, which is the phenomenon of a changing magnetic or electric field's effect on electricity or magnetism? The correct answer are the following. So the microphone, computer unit, headphone, studio monitor, and the audio interface are powered entirely or partially by electromagnetic induction. Although audio cables may be affected by the electromagnetic interference, basically, these are supposed to be shielded to work most effectively and do not use electromagnetic induction to operate. So they're not really requiring electromagnetic induction to operate. But they could be affected by the electromagnetic interference. There's a difference. Now, moreover, the digital audio software is just a computer application on virtual studios. Thus, it does not also operate on EMI principles. So it's just a software. It's not really something that has hard parts or mechanical parts. All right. The key concepts that you should have learned from doing the second part of Activity 1 for the record, my own home recording studio for life, are actually as follows. First one, many of the recording technology are founded entirely or partially on the relationship between electricity and magnetism known as electromagnetic induction. So, our recording industry, the way your favorite songs are made and broadcasted, they all require some understanding of electromagnetic induction. Now, devices that detect or convert audio inputs to electric outputs or vice versa are called transducers. Most transducers, like microphones and speakers, use the generator effect characterized by the production of forces due to a changing electrical signal within a magnetic field or a changing field near a current carrying conductor. All right. Now that we have a beginner's understanding of how electromagnetism works and how it is used in real life, I hope that in the next sessions we will be capable of kumbaga, understanding it even further. For this second session, we were capable of finishing the following. The first one was a pre-assessment. It was a multiple choice pre-assessment about different concepts, different words that you will be encountering in Module 1, electricity and magnetism. The second part naman was the first part A, of Activity 1. For the record, it was a virtual tour of a radio broadcasting studio, and in our case, we used photos to do this activity. And then, the last part of this session was the second part B of Activity 1 for the record. It was titled My Own Home Recording Studio for Life, where we matched the photos with their names and as well as their functions to make a code. Remember that in this video lesson, session number 2, we were tackling the following learning competency. Cite examples of practical applications of the different regions of electromagnetic waves, such as the use of radio waves in telecommunications. I am Sir CJ, and I hope that I will see you in the next video lesson related to Physics 10. Have a good day.